I was thinking about a concept of being able to connect two devices together over pretty much any network for the most part. And something like that already exists, technically. It's called peer-to-peer, right? And I've known of it for years from concepts like WebRTC. You got also like uTorrent and stuff like that. I remember it from like PSP, where you would be able to set up like an ad hoc game with your friend or whatever. And I have known of it for a while, and it's really good. But there was one inherent problem that I didn't like about it that's actually purposed that way. It was actually built by design, and that is that you can't have a persistent connection. So if you're setting up a peer-to-peer network, you will be able to stay connected with your peer just as long as that connection doesn't break. And if it does break, you have to manually reset this up. There's no real way to reconnect afterward, and it's by design that that is the case. Now, normally to solve this issue, you would just have a server, right? Like, at the end of the day, just have a middleman be able to communicate and be able to re-authenticate yourself through this middleman. Call it a day. However, for the specific situations and things that I've been looking for the past couple years, I want to make projects and develop things that don't require for me to have a server to have online for something to work, right? And there are a lot of different scenarios where I've thought of this. For example, in my one project that I have for the Google extension that I made that allows you to do YouTube TV watch sharing, kind of like a Netflix party for YouTube TV, that uses WebRTC and basically uses a peer-to-peer network framework. And it's great, but again, if you lose that connection, you have to reset this up with the other person on the other side, right? So that's not good. And usually for other places like, I believe, Netflix Party or Teleparty or whatever they call it now, they actually have a middleman server that handles the communication and connection between you and someone else. So that, again, doesn't really matter because that is an actual company and my application is just an open source project, right? Another project that I'm doing is the social media scheduler. It works great on desktop and it works great on Android, but there is a serious roadblock on iOS. For iOS, you aren't able to actually run background processes when your app is completely terminated. And since it's a social media scheduler app, you need to be able to post whenever the time is necessary or whenever you set the schedule, right? So obviously, if your app can't run in the background or if a scheduler can't be ran in the background to do things, then your phone can't be the main place for that. And again, other companies have a resolution for this. They just use their own server, so you use their servers to have your content and other information there so that they can be able to manage it accordingly. But again, the social media scheduler app that I've been working on is open source, and I'm not trying to manage anything in particular for it to work, which makes it a lot more difficult to be able to set up something for a lot of the purposes of a social media scheduler app, right? And one of the solutions I've been thinking about is to have it so that the phone device on iOS is kind of like a client and it can be able to communicate with another device that you have. Let's say your MacBook, laptop, or desktop or whatever, right? And so therefore you can have a main centralized place and you can be able to connect your phone via whatever method you have and be able to communicate directly to your Mac device. And that's what I was thinking about a lot. So I kept thinking about this, and the first idea I was thinking about was maybe I could do something with peer-to-peer, but find an automated way to kind of keep in contact with the other side. If you somehow disconnect, you can be able to figure out what is necessary to reconnect, so to speak. And when I first looked into this, I kept getting a lot of failure. I kept thinking to myself, I don't need to know the underlying understanding of peer-to-peer networks. All I need to do is just kind of figure out the flow process of like what kind of happens and then try to automate a solution from like sending the information and receiving the information. Because the idea or goal is that you would have to send over an offer or an answer to the other peer. They send you back an offer or acceptance of their information, and then from there you could basically be able to connect the two peers together. And so like in this example from this side here, this would be like peer A, and there are decorators and states to be able to connect, know the state of the connection, and to make a message, right? And my idea and goal was to kind of see if I can like automate resending out a offer if for any reason the connection state was like failed or closed in particular. But I realized over time that that's not essentially how that works. As you can see here, I have peer A, peer B, and the automation works if everything is in the same LAN. I basically used a small little TCP server to be able to communicate between peer A and peer B to keep that like kind of signal open, but obviously that wouldn't work in the real world. So obviously, even though you do see the actual persistent connection, like if I disabled this and disconnected, it would reconnect. But like obviously that's again because peer A and peer B are literally on the same computer, so this wouldn't work. I'm going to need to know really what makes up P2P networks and really see if it's possible to actually make something persistent. We'll need to actually know more about the concept of stun, turn, and ice. The biggest importance is going to be understanding more of what ice is, how ice works with its candidates to be able to then like communicate on the other side. I started to realize that stun was not as important. I thought I could hijack to be able to pass an information to it to the other side to like keep the persistence myself with like some sort of custom information inside the JSON, but it actually doesn't send over JSON information. It actually just helps the peer discover their IP address and port behind like a network address translation. And this is where my first idea was, where I was incorrect, but I'm going to still kind of keep the idea. I kept thinking to myself, oh, what if I just send a public and private key, send over the information that I need to peer B, and then from there be able to use that as validation for being able to like reconnect. But over time, like I found out that that was not the answer. Stun servers don't store or route any custom data, right? So I thought that it would have the offer information a part of it. You give the offer to the other person, and that basically allows you to connect with like the information, but there's nothing inherently that the stun server has that you can actually go off of, right? So I can't hijack the stun server to do anything custom, if that makes any sense. It's like, can peer A use the same stuff over and over? Meaning, can it recreate with the exact same information? Simple answer for this, no. Peer A must generate fresh ICE credentials and candidates. This was the part where I was thinking I can be able to break into this to make the persistence. I wasn't sure, but I felt like this was a good lead, right? And then it talked about ICE ufrag / password pairs and candidates are not reusable. And then I say, is ICE fully local? You know, it's just a lower level concept, not something on the internet. Like, I was just trying to make sure there's nothing else past this. This is just a concept, right? And it said mostly yes. It is a local negotiation process that runs on each peer, A and B, gathers local IP import information called candidates, optionally queries stun intern servers to discover public-facing IP ports, pairs if behind network address translation, right? And tries combinations of public IPs from both peers to establish a connection. The actual ICE protocol and logic are on the devices themselves. The internet only comes into play if you use the stun intern for mapping or relaying or punching through. And so I say, so ufrag and password pairs are only not reusable because it was written this way, right? Like, there's no inherent physical thing stopping it. You're just writing it this way, right? And it said, correct, there's no inherent physical or protocol level limitation preventing reuse of ICE username fragment and password pairs. They are technically just authentication credentials used during ICE connectivity checks and tied to a specific SDP session, right? However, They are defined in the ICE specs as single use for security and session integrity reasons. Prevents replay attacks and cross-session confusion. And this all makes sense for what its purpose is. Like, that's the spec or protocol and what its intended use is for. That makes sense. And so I say, nah, instead I don't want to be incompliant and just make my own ICE and call it something else, but use private public key instead of password. It is meant to not be single use, thus the name of the project being what I called it, persistent peer-to-peer. I'm gonna have to actually go like right into a real library repo that is basically the actual full concept, right? So I went and got libnice or libinice. So that's about it for this video. If you liked the video, please leave a thumbs up and please subscribe. If you had any comments, concerns, questions, please feel free to leave them in the comments below, as I love interacting with everyone. And other than that, I hope the rest of your day goes well. Peace, everyone.